physics students, today we're going to learn all about vertical motion. So before we get to the formulas/equations and how to use them, I think it's important to understand the concept behind how vertical motion works. So we're going to be looking at two scenarios, one in which we are dropping something in free fall, and then one in which we are throwing an object straight up and down in the air and seeing how the vertical motion looks like. How can we describe the velocity and acceleration at each point of that object's journey? So let's go ahead and start with free fall. So we're going to look at this dropped ball ticker tape, and how this ticker tape is going to be formed is with a strobe light. And so this is a strobe light. It's going to be flashing, and as it's flashing, pictures of this ball that's being dropped will be taken at even time intervals. So this drop ball ticker tape is really just, again, an object in free fall. So let's go and take a look and see what this ticker tape, so to speak, is going to look like for an object in free fall and what this ticker tape means. So he just turned on the strobe light, and now he's just going to be dropping the ball, and pictures will be taken at even time intervals, as you can see in this. All right, perfect. So here's the final image. Okay, I'm going to pause that really quick, and that's the final image, and I'm just going to crop this portion, and that's what we're seeing on this next slide. So again, we took multiple pictures of the ball in its journey as it was dropping towards this box on the ground, and we just basically overlay them on top of each other to get this, if you could call it a ticker tape of an object in free fall. And so just as ticker tapes work, as you can see, the distance between the ball is really small to start, and it gets bigger as the ball goes down. So if we know that every time the picture is taken is an even time interval, that tells us the ball is moving faster and faster as it travels toward the ground. So the question is, why does that happen? Okay, so basically what I did is I just took a sampling, maybe let's say like the first 5 balls in the image, so 1, 2, 3, 4, 5, and I know that it's a very similar pattern as it moves down. It's going to have wider and wider distance between the ball and the picture. And let's just go ahead and label this diagram with what's going on with velocity and what's going on with the acceleration, okay? Because obviously this ball is speeding up. There has to be some kind of acceleration happening to this ball. So the very first thing is, well, at the very start, when he's holding the ball over here, the velocity is obviously 0, okay? Then as we know, once he drops the ball is moving in the downward position. So I'm going to represent the velocity using an arrow, which is going to help us represent vectors. And again, vectors have both direction, which is represented by an arrowhead in the direction the arrow is pointing in, and magnitude, which is represented by the length. So at this first point in time, the ball is obviously moving downward because in the next position it's below. Okay, so it's moving downward. When I'm going to draw the arrow in the next point, which is this third ball over here, it's going to be also moving downward. However, we know this ball is now moving faster toward the ground, okay? So now my arrow is going to be longer. So velocity is a more negative velocity. In this fourth ball, same pattern. So we're still moving in the downward direction, but we're moving even faster with a greater velocity magnitude. And then finally, this fifth ball over here is still pointing down. We're still moving toward the ground with an even greater magnitude because this ball is moving faster and faster. So as you can see, there is a change in the length of the arrow, not the direction. They're all going downward, but in the length of the arrow. And so what does this tell us? It tells us that there is a change in velocity, meaning there is an acceleration. And because this ball is speeding up, that acceleration is going to be in the same direction as the velocity. And so as you can see, okay, this object is being pulled toward the earth by the force of gravity. And the acceleration due to gravity, as we've learned before, is g is equal to negative 9.8 meters per second squared. We're adding the negative here because it represents that gravity, this acceleration, is in the downward direction. Okay, and we're defining down as negative. So in other words, At this point in time, when the object is in free fall, gravity is acting on it, and that's what's causing the ball to go downward. At this point in time, gravity is acting on the ball as well, and it's causing the ball to move downward even more so because it's causing the object to speed up. At this point in time, there's gravity as well, again, pushing the ball in the downward direction, but even faster, and so on and so forth at every single point in time on this ticker tape journey. Okay? What about a vertically thrown ball, like a ball that's thrown straight up and then it moves back down? So if you can imagine in your head, if I was to throw an object straight into the air, it might start here. Okay, it's moving relatively quickly, and so maybe the next point in time, if I did a ticker tape, I would take a photo and it'd be here. And as it's moving toward the top, what happens to the ball? Well, if you imagine in your mind's eye, or you can even grab a ball, and I encourage you to test it out wherever you are, a ball object that's safe to throw up into the air, straight up and down, you'll notice that as it reaches its max height, it's going to slow down and reach a point in time where it reaches its max height, it stops, and then it changes direction and starts to move downward. Okay, so what we want to do is answer what is happening with the velocity as the ball travels in the upward direction. So first of all, I'm going to throw the ball into the air, then throw the ball up. In this case, it means it's going to be a positive velocity. And as the ball is traveling up, we just discussed, it is slowing down, okay? So let's draw that in terms of arrows. So the first point in time when I throw the ball up initially, there's going to be the most velocity in the upward direction, but it's going to be slowing down as the ball moves up. And so these velocity vectors are going to be getting shorter and shorter and shorter until we reach the very top. And at the very top, at the max height of anything that's being thrown into the air, the velocity is really zero. It stops momentarily before it actually changes direction and starts to move downward. So what happens with the velocity when the ball travels downward? It's going to be a negative velocity because now it is moving back toward the earth, and it is actually going to be speeding up in that negative direction, okay? So it's basically you throw it up into the air, it's moving quick, it slows down, it stops, and then it's gradually going to get quicker and quicker and quicker as it moves toward the earth. So the question is, what is causing the ball to slow down as it goes up and speed up as it travels down? Well, if you think about it, the one thing that these two things have in common is the acceleration has to be a negative acceleration, okay? If you have something that has a positive velocity and it's slowing down, that means the acceleration is the opposite sign. It's going to be a negative acceleration, sorry. If it is something that is a negative velocity and is speeding up, that means that the acceleration is in the same sign as the velocity. So it's going to be a negative acceleration. So what is this one thing in common that has a negative acceleration that causes things that you throw into the air to come back down? It's good old gravity. Okay, so gravity is acting at every single point in these in the ball's journey over here. It's causing the ball to slow down as it's moving up. As you can see, the gravity is working against the upward velocity, which eventually causes the ball to slow down and stop at the top. And then because there's gravity acting even at the top, it's what's pushing the ball in the downward direction as the ball falls back down toward the earth. All right, hopefully that helps you conceptualize the fact that every time you solve a vertical motion problem, there's going to be a given value that is kind of implied, and that's gravity. Anything that's thrown into the air or dropped from a certain height is going to have the acceleration due to gravity acting on that object. So I hope that was helpful. Go ahead and watch the next video to practice solving some vertical motion problems. Thank you so much. And I'll see you in class.